Alright, so today's video is going to talk about dimensional analysis. This is also nicknamed train tracks because the process that we go through kind of looks like you're putting train tracks on. So it's just kind of a fun little term that it's used, and it's easier to say and a little less intimidating than dimensional analysis. So we're going to get going with train tracks and how to use them. So first of all, why do we even bother with it? So first off, it's useful when converting between different units. For this first unit, it's going to be relatively basic and simple stuff, where we're just going between like different units of length or volume or things like that. But while there are easier ways or maybe simpler ways to do it, this is going to eliminate a lot of mistakes that you would get when you're moving the decimal point. It makes it a lot easier to convert when we are doing anything that's not metric, so anything that would be more than the decimal point. So things like feet, inches, fluid ounces, gallons, really anything we use in America is, as you know, is a giant pain to convert. Trying to remember how many ounces are in a pound or ounces in a cup, because of course we're going to use ounces for both of them. But anyway, the train tracks will make that process much easier to figure out. And then if we have multiple units that we have to go through, it's going to make it much quicker that way too. Plus, later on this year, when we start getting more in depth into actual chemistry, train tracks are going to be absolutely necessary to use. So right now we're just trying to learn how to do it with just simply converting units, so that whenever we get to the more difficult stuff, all you have to worry about is just the new stuff, and you're already train track masters, and you can fall back on that. So again, train tracks what we set up to do conversions, and all you have to do is just follow these steps every single time. And I promise you, it will not be difficult. Just stick with the steps, make sure you write them down very clearly in your notes, so that whenever you go to do the work or to do homework later on, all you have to do is just follow those steps. Eventually you'll start to learn the steps, because they do kind of make sense. You do this, then that, and it's all kind of logical. But at first, it may be a little bit tricky to get unless you have everything right in front of you. So just write yourself some good quality notes down, and it's going to save you a lot of time and hassle in the long run. Okay, so to go through the steps involved, it's a lot easier to just work through a problem than it is to say, well, you need to do this, then that, then that, then that. It's a lot easier to just to watch it unfold. So we're going to work this problem out. We want to know how many milliliters are in 2.5000 gallons, knowing that there are 3.6 liters in every gallon. So the first step is to set up the train tracks. So we're literally just making some kind of cross thing like that, where you have a long horizontal line and then some vertical line. You also will usually want to leave some space out on the right hand side, because sometimes these tracks may get extended out. They could extend out 2, 3, or 4 places out from there, or it could just stop here. It depends on the problem. But always leave yourself a little bit of space until you get to the point where you can see roughly how much space you're going to need. So step 1 is just simply do that. You should have no problems there. Step 2, we're going to take the given amount that we have and place it in the top left box. So the given amount that the problem stated was that we had 2.5 gallons that we're going to eventually convert to milliliters. So the 2.5 gallons, that is what was given to us, or the information in the problem. So we're just going to simply put that on the top. Now, if we had a unit with 2 different measurements in it, so maybe we're doing something like miles per hour, we would put the however many numbers of miles up top. And then because it's miles per hour, whenever you write it out, it's kind of like a fraction. So you have the miles, and then there's the slash, and then there's the hour. So that's essentially all these train tracks are, just a bunch of different fractions. So instead of miles slash hour, you can think of it as miles over hours. So you would put the miles there and the hours there. Anywho, don't worry about that too much at the beginning, especially as you're just trying to figure this stuff out. We're just going to stick with 1 unit during the notes for simplicity's sake. So again, just put the unit up top with the given. The next step, we're going to move the unit from the top left down and diagonally to the right. So we had gallons up in this section, so we're going to put it down here. The reason for this is the point of train tracks is we're going to cancel things out. Because remember, if you can divide a number by itself, it comes out to 1, which basically just disappears when you're looking at multiplication and division. So that's the ultimate goal of putting units on top and bottom. Now, you can't just automatically just throw gallons on the bottom and just eliminate it entirely. Just like with math, like when you're doing algebra, if you multiply one side by something, you have to do the same to the other. So we have to play fair and give an equivalent thing up top. So we'll put the unit that we can get to next, which was liters, because that conversion, or the beginning of the problem, gave us a conversion between liters and gallons. So the next unit that we're going to is going to go up top, because eventually we're going to plug numbers in here that basically come out to be the same. It could be the same thing as if I was trying to go between single units and a dozen. If I have single units down bottom, that would be 12 units for every 1 dozen. Those two are exactly the same thing, and so we can put them on top of each other. Just like if we put 2 plus 2 over 4, that's going to come out to be 1. So that's kind of what we're doing here, is we're trying to cheese math a little bit to work out for our advantage. But anyway, the next step is to put the next unit that we're going for. Then from here, if we haven't reached the unit that we want, we need to add another track. So we're at liters right now, and so we need to get from liters now to milliliters. So we're going to add another track and extend it on. That's what I was mentioning earlier. And then we're just going to keep going through steps 3 through 5 until we've gotten to the unit that we want. So of course we're going to put liters down bottom, and then we can go straight to milliliters, because if you remember from middle school science or biology or things like that, liters and milliliters are both metric, and they're the same thing. It's just one of them is smaller than the other. So we can go straight between them. We'll get into how to do that here in a second. So the next step is to fill in the numbers with the conversion factors. Excuse me. So at the beginning, we saw that there were 3.6 liters for every 1 gallon. So we put the 3.6 with the liters, and we put the 1 with the gallons. Now for the milliliters and liters, that one is a little bit trickier, but at the same time super easy. So if you look on your periodic table sheet, on the very back of it, there's this metric system thing up here at the top. If you can't remember the King Henry died, whatever the acronym was, I forget what it was that you learned in middle school to remember kilohecto, whatever. If you can't remember that, always use this. You're going to have it for every quiz and test, so you may as well get accustomed to using it on your homework so that it becomes second nature. So the easiest way to use this is, we know that we're going between liters, which is going to be our base unit here, and milliliters, which would be over on this side. Now everything on the left, and on your sheet you may want to write this down so that you kind of get used to it. We have bigger units that are over here on the left, and our smaller units are over here on the right. Plus, if you just look at the prefixes, mega obviously means big, micro obviously means small. So you know we have big things over here, small things over there. When we're trying to convert between these metric things, the easiest way to do it is to start with whichever unit is bigger. So since we're going between liters and milliliters, we're going to start with liters. It's bigger because it's further to the left. So on our train tracks, we're going to put a 1 with the liters because it's the bigger unit. This is the only thing we put 1s with, the automatic bigger thing. Everything else, it just varies from unit to unit, thing to thing. This is the only time you're going to automatically put 1s somewhere, is when you're using your metric system chart on your periodic table. But then next, we need to figure out how many milliliters, or where that 1,000 came from. So as we look, we're going to count over dashes. Don't count over spaces, go by the dashes. So I know that I need to make 1, go over to 1 dash, go over to the second dash, and then lastly, I'm over at the third. So we can go 1, 2, 3 spaces over, or 3 dashes over, and we're going to wind up at milli. Since we went over 3 places, that's how many zeros we're going to put behind the 1. So that's going to be 1, 2, 3 zeros, or there are 1,000 milliliters in 1 liter. This would also work, let's say we wanted to get from hecta to micro. We would put a 1 with hecta because it's the bigger unit. And then we're going to count over 1, 2, 3, 4, 5, 6, 7, 8. So you would put 8 zeros after a 1 for the micro. So it would be, I don't know, a really big number, like 10 billion or something like that. Something kind of big and obnoxious. But that's how you use your thing there. But anyway, so you just plug in the numbers where they're supposed to go. And then, by the way, the conversion factors, there are a couple different ways there. Look. I'm not sure why that got chopped off. Hold on a second. Okay, fix that real quick. So conversion factors are going to look like one of two things. It will look like a number of unit 1, so like some amount of unit 1 is equal to some amount of unit 2. And you would just simply put the numbers in for where the units were. Or the other option is going to be numbers of unit 1 per unit 2. So the first one's going to be a little easier to use because you literally just put whatever this number is with that unit, put whatever this number is with that unit. The lower one down here, though, is going to be a little trickier, but it's still very, very simple to use. So numbers of unit 1. So let's say we're looking at like miles per hour because that's a conversion or a unit that we use basically every day. Anytime you get into the car, you're keeping track of your miles per hour. So if you're going 35 miles per hour, that means that the number of unit 1 is going to be 35 miles per every 1 hour. So the 1 isn't there because just like everything else in math, if you just have an x sitting in an equation, how many x's do you have? You know there's 1 there. There's no reason to write the 1 in front because it's already kind of assumed. So it's the same way when you see things written like that. Number of unit 1 per unit 2. That's just saying there are that many of unit 1. That'd be great if this thing would go away. For every 1 of unit 2. So, once we get our numbers in there, we want to make sure that our units cancel out. So by canceling out, remember that's the thing we mentioned at the beginning, where anytime you divide the top and bottom by the same number, it winds up canceling down to 1. So looking here, I see I have gallons on top and gallons on bottom, so I can cancel them out. Liters are up top and bottom again, so I can cancel those out. And I'm simply, the only unit that's left over is going to be milliliters. So I'm going to be able to keep that and solve the problem from there. Then this is one of the last steps. We're going to multiply the top and bottom separately, and then we'll divide them together. So 2.5 times 3.6 times 1,000 milliliters is going to be 9,000 milliliters. Then 1 times 1 is obviously going to be 1. We divide 9,000 milliliters by 1, and we wind up with 9,000.0 milliliters. By the way, the reason I kept that 0.0 there is because I want to keep track of my significant figures. So if you remember from the sig fig notes, anything that comes from conversions or a reference sheet does not count when you're trying to do sig figs. So both of these numbers came from a conversion that was given to you. Both of these numbers came from a reference sheet, so none of those 4 are going to factor into trying to figure out how many significant figures my problem needs. So the only number that's going to do that is this guy here. And since I was multiplying and dividing the whole time, my answer needs to have as many sig figs as the smallest number that we cared about, which is this one. So this guy has 1, 2, 3, 4, 5 sig figs, because all 3 of those zeros are on the end and there's a decimal, so they count. So our answer needs to have 5 sig figs.